give us enough information there. 1 to 3 and 2 to 3. And if I ask you to find, let's say, from 1 to 2 of f of x dx, we did problems like that on Tuesday. And again, I don't know if this helps you guys or not, but I like having the little number line here and putting those things in because I'm kind of a visual person. If I can see the relationship, it helps me out. And this first piece tells me if I go all the way from here to here, from 1 to 3 I get 5, and from 2 to 3, this piece here, I get -2. Okay? So now if I want to know what the area is under the curve from 1 to 2, I know the whole thing is 5. I know that this piece is -2. Also, from the problem we did earlier, remember how we did the one A to B and B to C and we added them together and got the total? Well, I know that if I add this number, whatever it may be, we'll call it A, if I add that to -2, I should get what is my answer? 5. So what can I add? 7. So the area under the curve from 1 to 2 would be 7. And that's simply because I know that the total from 1 to 2 and 2 to 3, I have that total. It's 5. So I know that if I add my answer to -2, I get an answer of 5. Well, it's not really on a number line. I'm just looking, the graph might look something like this. Maybe it's here, and then it comes back underneath, and maybe this is, well, okay, let me just, that's 1, there's 2, and there's 3. So that this area right here is -2. But when I add it to the area right in here, I'm supposed to get 5 out of it. And so that's where that would have to be +7 to make that work. So this situation illustrates a graph that our areas, if we do the antiderivative and do a definite integral from 1 to 3, our answer is not really the total area. What if I did, remember doing these from, let's say, let me think here. If I ask you to do the interval from 4 to 5 of f of, let me make sure I get this the right way, x minus 2, all in parentheses, dx. You had some like that on your worksheet. Peter, stay with me, because these are the ones that get a little confusing here. Yes, Margaret? How did I get 7? Yeah, I mean, you have to think, what number can I add to -2 and get an answer of 5? So it's like saying a plus -2 equals 5. So you add 2 to 5 and get the 7, because you have to add to the other side. All right, now what did this do to the graph? This -2 right here shifted the whole graph which way? To the right 2. The whole graph. So if the whole graph has been shifted to the right 2, where were these original bounds? Because I've taken some numbers and I've moved them by adding 2. So if you will remember, what we discovered on Friday is that if you do a horizontal shift like this, you can take your bounds and actually do what it tells you to do to the x. So we could actually subtract 2 and get back to where we started. So that would be 2 and 3, I heard somebody say. And that's the same then as this piece of just f of x. So what would my answer be? -2. So if I shift it left or right by putting x plus something or x minus something grouped together in parentheses, and I give you the new bounds, all you have to do is whatever it says in parentheses to get back to your old bounds. And we did some of those on Tuesday, so when you get your worksheet back after I've recorded those, you may want to glance at them and make sure you remember how to do those. What if I do, and this was the second example, what if I do a vertical shift? So in other words, I do, what were some of my bounds here? 1 to 3. So let's do, still from 1 to 3, but I'm going to do f of x plus 5, that quantity dx. So now my number that I'm adding here is not inside with the x. So what does that do to my graph? It moves it up 5. And do you remember that that sticks a box underneath the graph there? In this case, it's going to be a rectangle. So we have our graph, and we're just basically moving it up 5 and creating this rectangle. I kind of drew that backwards because it's actually going to shift up higher than it is. I moved it up 5, so I've got this box. How wide is it here? Do you remember how to find that? It's, use your bounds, because what piece of the graph are we looking at? We're looking at the area from 1 to 3, and so how wide is that piece of the graph? It's 2 units wide. I just take 3 minus 1. I think you said -2, so you were on the right track. 3 minus 1, so this area right here, we're going to add 10, and then see our graph is up here doing whatever it does. And this area under the graph is still the same, which I probably had some going below the x-axis, but I won't mess with that. It was 5, right? So I have to take my 5 of the normal area and add my rectangle in. So the total would be 15. So if you move it up or down, you add a box. And that's pretty much everything we've done with fundamental theorem of calculus. So is there anything there that you need to ask about? Because I'm going to shift over and do some review. Okay, the 10 on the box. The 5 comes from the shifting up 5, and the 2 comes from, like if this is my bound here of 1, and here's my 3. 3 minus 1 is 2. That's where that comes from. So I multiply the 2 times the 5 to get the area of the rectangle. And then I add the 5, and that 5 came from the original numbers that I gave you. Because I gave you back up here, I gave you this piece right here. Because the original graph had an area of 5, but when I moved it up, I created a box underneath it. Margaret? Would I, okay, right here, would I always get what answer? And I get -2? No, you will not always get that. That just was by luck, because I just was making stuff up. This answer up here is where that came from. It matched, once we shifted things around, it matched that perfectly. So no, this -2 does not come from the -2 up above at all. It comes from our original numbers that I gave you. Okay? Anything else? Alright, we're going to shift over and start doing some review for the test. I don't know if I'll get through all of it today because I don't want to bore you to death, but